Chapter 3, Exponential and Logarithmic Functions. 3.2, the exponential functions. Okay, the difference between the previous topic, now we have the words of the exponential function. Okay, this is special type of exponential function. Okay, where we call this as natural exponential function. The objective is to solve the natural exponential function. Okay, what is natural exponential function? It is denoted by symbol of e. You can find in your calculator button, and you need to know how to press e correctly. The most important exponential function is e to the power of x, where e is defined as this definition: e equal to 1 plus 1 over m power of m as m goes to infinity. The table illustrates what happened to the expression of e. Okay, so as m is increasing, look, m column from 1, 10, 100, 1000 and so on, this value keep increasing, but it reach a certain value. For example, if m equal to 1, the e value equal to 2. If m 10, you will get 2.5, 100 2.7, 1000 2.7, and eventually it will reach a certain number, 2.718, right? So in conclusion, the value of e, which is natural exponential, equal to 2.718. You can press your calculator, you can hit the button e and 1, e power of 1. This will equal to 2.718. E is called the natural exponential function, where the irrational number e is called the natural base. Why study exponential function? Okay, exponential functions are used in our real world. For example, to measure growth, interest, and decay. Growth obeys exponential function, for example, rumors, human population, bacteria, computer technology, nuclear chain reaction, compound interest. Another example that follow the decay behavior, for examples, carbon-14 dating, half-life, Newton's law of cooling. Okay, now let's answer this example all about exponent, natural exponent, all about e. So how to solve this? It still follow the rules of indices. Okay, you can refer to mathematical formula book page 7. Now question A has the same base. Okay, both are e, and the difference is on the index, and it is connected to this multiply symbol. So now this equal to e to the power of 12, where we added 3 plus 9. Okay, question B, e to the 9 divides e to the 7 equal to e to the 2, because 9 minus 7 equal to 2. For question C, you just need to multiply the index, so it becomes e power of 36. For D, you have a power on the outside of the bracket, means that each element inside of the bracket gain the same power. So this is the answer. Now, how to sketch the graph of y equal to ex? Similar to the previous topic, to draw the graph, we have to construct a table. By putting some value of x and y, you can plot the curve. Just take some value of negative and some value of positive. Okay, and then you use this function, substitute the value of x. Okay, for negative 10, you will get 4 times 10 minus 5, 0.3, 1, 2.7, 7.4, 20.1. So on the graph, you can plot. at minus 10, it's almost 0, so it's very small number. Minus 1 is 0 0.3, 0 is 1, 2 is 1 is 2.7, around here. 2, 7.4 is around here, and 3 is 20.1. It's not here in the screen, so we know that the pattern is just increasing. You just draw a smooth curve with the growth trend on the right hand side, while on the left hand side is approaches 0 but not touch the 0. Okay, it's like this. So this is y equal to ex, and the labeling of y and axis curve. So that is the sketching. Now we want to answer the domain. The domain is the all possible value of x, since the curve can be extended left and right. So the domain is from minus infinity to infinity with open brackets on both ends. For the range, the curve is covered on the upper part only, means that from 0 to infinite, and we put open bracket as well at 0 because 0 is not included. Okay, example. Now there are 3 curves on the same graph. What's the difference here? Look at the coefficient here. We have 2e. What is e value? Remember that e is 2.718. Okay, and we have 4. 2.74 means that as this number increases, the curve become very steep. Okay, become very steep. So that is the trend of the exponential functions.